Hi guys, after a very long time, welcome back again. I'm really sorry I couldn't upload in the month of February the last part of the CML molecular monitoring. I went to a couple of conferences which were very good in the last month, and I met some of my subscribers who told me that why am I not uploading very frequently now? So the reason I'm not uploading very frequently is because I'm very busy with a lot of work related, my job related commitments. But this is the best that I'm able to do. I am really sorry that I'm not able to meet up to your expectations. YouTube has an algorithm where if I'm not uploading very frequently, they'll not recommend you my latest videos. So if someone is, I mean, whoever is seeing this, I request you to share, because when I'm not very frequent in uploading, and if you do not share, if you just see, the other people who may not see all my videos but maybe see some of them, they will not get a notification that I have uploaded a new video. Only the regular viewers will get it. So I request you all to share it, so that with your friends and your peers, so that those who do see my videos but not very frequently, maybe some particular topics, they do get a notification that I've uploaded. So very quickly moving to the ELN treatment, I had taken in detail about the fish, how the fish is done, what you see in fish. So we have interface fish. That is what we read in CML. We see the BCR ABL translocation and fusion gene, which you can see on my channel in the previous video. Then we have quantitative and qualitative RT-PCR, which is again one of the most common things which are done. Quantitative RT-PCR is more of a follow-up method. Of course, in developed countries, it is done at the baseline. This chart is from ELN, which is European Leukemia Net. So in India, we might not be able to perform a quantitative PCR every time, especially when the baseline patient comes. So we just do a positive or a negative, which is qualitative PCR. However, it is advised that we should also do a quantitative PCR to see the log reduction. However, even in a developing country like India, where financial resources are a constraint, on follow-up of imatinib treatment or the TKI treatment, we do a quantitative PCR after that, so that we can see the log reduction in the molecular burden of BCR-ABL translocation. CML is one such leukemia where morphological remission is not very important. What is important is molecular, and then maybe if required the cytogenetics, but mostly we just go for PCR and see the remission. Again, cytogenetics is mandatory. Mandatory is molecular, but remember that in your setup it might not be so. But molecular, yes, we have to do. NGS panel mostly done. In my previous lectures, when I was taking pathogenesis, I showed you that there are certain mutations which overlap between an MDS and a CML. So for that, when the patient is looking like a CML, maybe is a CML but not responding to a treatment, or is looking like a CML, you're getting, maybe you have a cryptic translocation and you are not getting the classical 922. And of course then the TKD mutation, which is mutation to the imatinib therapy. So see, interface fish is for a patient on treatment, fish is just a baseline diagnostic modality. Again, follow-up has to be done by RT-PCR and the quantitative version of RT-PCR. Okay. So this is the triangle which shows, see, BCR, ABL, this ABL1, BCR and GUSB. This is the, you can say, the gene which is used as a control in the lab which is performing the BCR, ABL, RT-PCR. So we see this as a control key, how many copy numbers have multiplied. We see the ABL1 gene against the BCR, ABL1. This is the control ABL1. And if our, say, my cutoff is 10,000, so if the 10,000 copies have multiplied over here for this ABL1, then my test is running right. Okay. So, or we can also do it for a BCR gene or a GUSB gene. Mostly the labs use ABL1, and this is synthetic. Okay. RT and RQ-PCR means quantitative and qualitative. So a 10% to mutation load is molecular response 1, 1% is MR2, 0.1% MR3. This is what we major molecular response. This is what we tend aim to achieve. A major molecular response of zero point 0.1 in say around 9 to 12 months, 6 months also. Fine. If it goes below 0.1%, then it is MR4 and M. That is log 4 or log 5 reduction is deep molecular response. This is like very good, very ideal, wonderful, like cancer cured in a way. But this is our dream to, like, this is what we want to attain, a log 3 reduction, where the tumor burden, the translocation is seen only in 0.1%. Okay, and this is that triangle that we should know for CML. Again, this is a graph showing the time duration and the PCR levels, which I've explained before. Any point of time, the molecular response varies. The molecular response increases. We have to get a mutational analysis for imatinib resistance check. Do remember that. Okay. So again, I've told you about this 10,000 ABL. This is the control against what we are actually reading. Okay. Imatinib resistance. So the resistance happens. This is the entire ABL protein area where you get a switch. So see, there's a latch and a switch mechanism. There are SH3, SH2 groups on the imatinib binding site, and a latch, like this protein binds over here like a latch, and it prevents. So what basically when we give the drug binds over here and it prevents the activation of this protein or this transcription point on the genome. Okay, and then proliferation cannot occur because tyrosine kinase helps in cell cycle proliferation. So the resistance occurs when this part, due to some mutation, gets blocked, and a constant proliferation signal is being given over here. See, this latches onto this. There's a phosphorylate group, and now a constant proliferation signal is being given, and the imatinib is not able to bind over here. Hence, the cell keeps proliferating, and that is how resistance to imatinib occurs. Okay. Again, same thing. So imatinib binds to the BCR-ABL enzyme over here. So the substrate which causes cell proliferation cannot attach. Now something happens that the substrate gets phosphorylated and permanently attaches over here. So cell will keep proliferating and imatinib will not be able to bind. This the T3I5 T315I. This is the most important mutation that we study when we predict an imatinib resistance. So I think that is it. I don't think I have any more slides. Let me see. Yeah. Okay, one more. So this is again the major imatinib resistant mutations that we study. So this was a very, very small, again, a very 8 to 10 minutes talk. You don't need to remember all the mutations, to dasatinib, nilotinib, bosutinib, ponatinib, or asciminib. So once we have imatinib resistance, we go to the second line, which is your dasatinib, nilotinib, then to the third line, that is ponatinib, and then asciminib is the latest. You don't need to remember size. So for instance, you just need to remember that T359 is the most important imatinib resistant mutation. The way they act is a latch and clamp mechanism that the imatinib will go and bind to the proliferating site of the PCR-ABL enzyme complex. Now, if this an imatinib binding site gets involved by a phosphorylation group, then what happens? Cell will keep proliferating because tyrosine kinase का काम है proliferate कराना. So now this inhibitor in the form of imatinib is not able to attach, and then that leads to cell proliferation. You need to know that triangle that I showed you: 10% molecular mutation burden, 1%, 0.1%, 0.01, and 0.001. Our ideal aim is to bring the BCR-ABL mutation load in the cell, that is the mutation load in the sample, to 0.1%, that is log 3 reduction. उससे ज़्यादा होता है deep molecular response, perfect. Alright, so role of morphology gets very limited until unless CML is transforming into a blastocyst. Only then does it matter too much. Otherwise, in a plain simple CML CP, AP hata diya. WHO has removed AP now. So there's no point of discussing AP. It's either CP or it is blast crisis. And then of course, then you should know that blast crisis occurs in various forms of acute leukemia. And then the treatment is similar to an acute leukemia. So I think that is all you need to know, and I'll just wrap up this small lecture. Thank you.